Content of this
Okay.
meeting is being sent to a third party. Who would that be?
Okay, there you are. We're on.
Here we are, gang. Hello, everybody. Astro freaks, cosmic nerds, the rest of you. I'm Ronnie Heron, welcoming you in to the Santa Barbara Astronomical Unit's weekly vlog podcast, number 201 on astrophysics and cosmology. We call it the SBAU Astro Hour. And it's episode number 201. We got 202 next week. And in November, or pardon me, March, 3 months, we will start our fourth year. We are part of the board and longtime members of Santa Barbara, California's 70-year-old telescope club, tackling a lot of incredible stuff, cutting edge discoveries. We got a lot of fun going through this every week. Doggone it. I haven't missed too many of these shows, and neither of you guys. Learn all about us at sbau.org or find us on the back side of the mission at the beautiful Museum of Natural History. Let me introduce you. Since I'm vice president, reelected, here's Jerry Wilson, our beloved president,
Good morning.
married to Pat Forgy, and just got reelected 7 years. We even met my predecessor, a young man who was 17 years old, came to our party a couple Fridays ago. And outreach coordinator, Chuck McPartland,
Hello,
awesome
hello.
man. Yep, married to Pat McPartland, his wife, another Pat, a merchandise manager in charge of most events himself. She's also the treasurer and was reelected, amazingly. Tom Whittemore joins us, editor of the monthly newsletter, former Westmont College professor. His wife is Maureen, and son of a gun, if there isn't Tim Crawford.
Hi.
Tim, I've got a consensus. They want you to turn the light off. I'm sorry, we can see your face. So
Oh, okay.
he's married to Karen, and he's one long time guy. And doggone if we don't have a great group. And we are going to talk about the moon, where it is, shining down, brightening the southeast sky next to the Pleiades. Christmas Eve flyby. Get this, a week ago. Well, within the last week, the Parker probe survived a close encounter of the third kind with the sun. Speaking of our moon, it's a crescent shape, shining near Venus and the west, and then it'll be near Saturn, I guess, in January. There's a compact group of galaxies out in Pegasus called Stephan's Quintet. We'll show you in this hour. For those of you who have problems with crabs, the crab problems, I got my mouse traps up around my house for them. We have Charles Messier's #1 M designation, the Crab Nebula, and we'll check out Canis Major, asteroid Eunomia, and the quadrantid meteor shower. But first, we got to have the silly science cartoons, platitudes, thought provokers that are always forwarded to us by our hardworking, beloved president, Jerry Wilson. Silly science coming to the screen, everybody. There's something I've always wondered about. You're going to have to enlarge it to let me read. It took me a while to figure this one out. What the heck are a bunch of corner signs, walk signs, meeting outside a UFO? Well, they're the creatures. Our people postponed on every street corner, Commander. Shall we commence with our plan to gradually eliminate those creatures? So now we know. The minute the hand goes up and never goes to walk, the little guy walking, we're in trouble.
Now, a couple of these we might have seen in past years.
Yeah.
That's true. You got Santa colliding twice. Here he is. There's no caption on this, or he just, what did he? Oh, he hit a UFO, of course.
The UFO hit him.
Yeah, well, there's another version of this. It's even sillier, which you may or may not. This is not the one you sent out this past week. That's an earlier one. Here
Okay.
he is needing his glasses. He stepped on him, and he doesn't know he's not climbing into a chimney. And there's a Vixen
Oh,
and
no.
Prancer going, "Don't do it, Santa! No!" It's where they breed black widow spiders. There it is. The
Yeah.
roams over New Jersey, and he says, "This is my last visit to this damn state." That's true. I guess they found that most of those are just normal planes. This one I liked. We're in surgery, neurosurgery, and the neurosurgeon says to his assistants, "We have to relieve the pressure in his skull, guys. So I'm going to go in and take out about 2 dozen passwords." Okay, and then a bunch of Christmas trees, some of them decorated, some are not, are sitting around playing, you ready? Strip poker. The guy on the right is doing pretty well. He has two
Yeah.
stars and more ornaments than
stars,
anybody. Okay. Is that the deal, or do they give each other the clothes they take off? I've never
No, it's,
played that game,
you
damn it.
got it.
Is that what it is? Well, they're being deflocked, or is it defrocked? I don't care. We're gonna have fun for the hour. I don't know where. Oh, Bruce is joining us.
Yeah.
I will
Morning,
introduce
Bruce.
him as soon as I see his ugly face. Bruce Murdoch, ladies and gentlemen, is about to join the panel, the crew of 6 of us. Until he gets here, we'll go to the boy who spotted the lost star.
Now, these
Oh,
4 slides were not in the stuff I sent out yesterday. These are from an email Chuck sent out. I
yes,
got it this morning about an hour ago.
I started reading it. E-Corpor, no, T-Corpor, right?
Corona Borealis, yeah.
Yeah.
T-Corbor, okay.
Oh,
And
TCR.
it's a regular event. It's not a Cepheid variable. It's one that just does its own thing every, what, 80 years?
It's a recurrent nova.
Okay, meaning it sloughs off stuff that it doesn't get swallowed by its little companion white dwarf.
No, the white dwarf sloughs up swallows up the stuff, and when enough accumulates, it detonates.
From the white dwarf.
The white dwarf detonates. Yeah, the surface of the white dwarf detonates, but it does not destroy the white dwarf.
Okay, but it's orbiting a red giant every 80 years?
Yeah.
No.
No.
Oh, it's not
It's
78.
every 80 years that the accumulation builds up enough to explode, it seems.
But they are binary.
Yeah.
Okay, well, there's more to this than just the picture, but here's the gentleman as he looks now. He's
Yeah.
in his 90s.
Michael Woodman, right?
Woodman,
yeah,
yeah.
interesting.
Wrote to Royal Astronomy, and they wrote him back a letter, and here it is.
Yeah, he wrote to the Astronomer Royal in England. And
They used typewriters back then, didn't they?
yeah,
Of course. That's a keeper.
let's see. Your observation may prove to be the earliest detection in this country of the brightening of T Coronae. So, yeah, he wrote to the Astronomer Royal, and the Astronomer Royal wrote back. And this is where it is in the sky. This is the constellation,
Otis.
yeah, Bootes. This is with the star Arcturus. This is what in England they call the Plough, which is the Little Dipper.
Big Dipper.
Excuse me, Big Dipper. And then you go, the article tells you, well, this tells you, follow the arc here down to Arcturus. And then up here is the crown. And T Corona Borealis is about what, 8th magnitude?
10th, I think.
10th?
Yeah.
Okay, so you will not see it with the naked eye. You might pick it up with a good set of binoculars, but it'll be right here. And it has a certain fluctuation in brightness that was seen prior to the 1947 eruption. And we've seen that over the summer here. So everybody's expecting the brightening or the nova event to happen relatively soon. So who will be the first to spot it this time?
Yeah.
Would our guys be able to pick it up on Star Party Saturday, the second Saturday?
It's a
Yeah, with
morning
our
object
scopes.
right now.
Oh, it's
Yeah.
a morning. Okay.
But with our scopes, we should be able to see it.
When it happened.
Now the
What
period
happens is you'll see it naked eye.
it's not 80 years, isn't it? 78 or something, Chuck?
It's 80, but they don't know that it's precise 80.
Yeah, there's yeah.
So that
It's
would put it
roughly
in
80.
2027?
26. It was 46 the last time it went off.
Oh, okay.
1940, the year I was born.
Hmm.
What is this at 2018?
This is the Parker probe taking
Ah.
off from Florida at night with you can see 3 rocket plumes. So it is a Falcon Heavy taking it off and putting it into
Yeah.
interplanetary orbit.
6-7 years ago.
Yeah.
Boy.
And on this date, which was a few days ago,
Mm.
they got a return signal. The Parker probe shut off its transmission, or we couldn't get it. during a period of closest approach to the sun. And when it came out the other side on this date, it said, "Hi, I'm still here." And so everybody gave, a reserved high happiness sign,
High
passed the
five.
coffee cup around.
Yeah. And then it turns toward Earth when it gets far enough away that it's not going to melt.
Oh, we'll come to that.
Oh, okay.
So anyway,
Bye.
to scale, if the from the sun to the Earth is 1 meter, the Parker probe was 4 centimeters from the sun.
Ooh.
It's inside the orbit of Mercury by a factor of 5.
Ooh.
So it was pretty hot. It is using Venus, these long elliptical orbits. It's using Venus to use up energy. So it swings a series of circular or elliptical orbits that this part of that orbit is slowly decreasing. And it just went through it went through 7 flybys of Venus. This is Venus orbit. There's Venus out there, Mercury. You can see Mercury's orbit, and the Parker probe is well inside. It's going to keep shrinking down, and nobody in these articles has mentioned what's going to happen next. Is it just going to, next time it's going to crash into the sun, which is my bet, or soon after this? Or are they going to use Venus or Mercury or something to try and pull it back out? So we'll have to wait and see.
That's what I was going to ask you, Jerry, if they can use Venus to slingshot it.
It depends where everything is placed and the timing of it. And I haven't read anything on that.
Boy, that'd be neat, man, if they could send it back to us.
Yeah, right. No, I know they're not going to bring it back to us. It's not prepared for a reentry.
Yeah.
Can I tell you what I've learned from this? The most heat resistant element is the one that we're made of mostly.
Water.
Water,
No, carbon.
carbon. Oh yeah, it's a honeycomb carbon heat shield they made for this.
Huh.
This is a representation of some of the images that it's taking. This is the sun, and it's rotated right for when this data was taken. So you can see streaks of brightness, and this is a single frame from a movie. And in the movie, these dots are dancing around because these are hits from gamma rays.
Oh.
And this was taken on March 29, 2024. Not nearly as close as it was a few days ago.
Going back to your orbital thing, the software that I wrote and that we presented a couple of years ago, if I know the current ephemeris for the Parker probe, I can tell you where it's going to be.
Okay. Maybe you could run your software and tell us where it's going to be next week.
All right.
What makes the gamma rays?
The sun is a good source of radioactive particles and electromagnetic waves.
Well, gamma rays are the most powerful of all. I thought they came from distant quasars and horrendously big stars and stuff.
Well, they do that, but they also come from the sun.
They're byproducts of the fusion process.
Right.
I also heard they come out of lightning,
Yeah.
Yeah.
which kind of gives me pause.
Stay away from lightning.
They were byproducts of the fusion.
Yeah, they are.
Wow.
But the X-ray machines use X-rays. They don't have one that uses gamma rays yet, do they?
I don't want to
Hard
get hit with
X-rays.
one of those.
Yes, they do. It's called a gamma knife. They use it to treat cancer.
You're kidding. No kidding, really?
Yeah.
Okay. Fascinating.
Okay. Moving on. We're now in the winter.
Oh,
There it
here we
is.
go. Here we go.
Winter triangle.
So
Yeah.
this is the famous winter triangle, Betelgeuse, Procyon, Sirius. This is looking southeast, and this is by far the easiest constellation to spot in the sky if it's up.
And it's not foggy.
Yeah, yeah, God, we have a lot of fog here lately. So this is the same area. There's Sirius down there, Betelgeuse, and
Procyon down and left a little.
Look, by Canis Minor.
oh no,
There.
there
There you go.
there.
Yeah.
Yeah, I keep looking at Gomisa. Anyway, that's the winter triangle here. The point about this that the Sky and Telescope makes is, or Astronomy Magazine, is that now you can extend the triangle with two equal vectors, one for Mars and one up here for Jupiter.
Hmm.
So it adds to the triangle. And this is a very, very rich region, the Milky Way going down here, and there's lots of nebula and star clusters along in here, and especially around in this area over here. And things like M41 down here.
The
Very
Pleiades.
far from. Yes,
Oh, that's the Pleiades?
Yeah,
Yeah,
the
I
I
Pleiades.
gotta look at that baby. I gotta see that one next summer.
It's wintertime.
It's winter.
Yeah.
Oh, it's winter.
It's
Oh,
winter
okay.
objects, yeah.
I gotta take a look at the Pleiades.
and the Hyades up here.
And then we got the winter Alberio.
Yeah.
So this is close to what we'll be seeing on the second Saturday for the star party.
This
Yeah.
is what it looks like at 10 o'clock. So you will see this. The star party runs around here, is around 7 to 9, probably.
Yeah.
Yeah, tennis when we have to start packing up.
Yeah.
And with the weather the way it's been, it's probably 7 to 7:01.
Yeah.
No, it's after midnight that the sky opens up, but then about 2 or 3 a.m. the fog comes in.
Oh God.
There's our president with whom?
This
Gary
is with
Saronic.
Gary Saronic.
Yeah.
He was the docent on a trip sponsored by Sky and Telescope magazine to see the eclipse in Queensland in 2012.
Australia.
And he's a very interesting and inventive guy. He still uses film cameras, 35 millimeter film cameras. Doesn't use digital.
Well, they have a much broader dynamic range.
Okay.
This is,
Coming up, the moon crescents down.
yeah, let me just catch up with my notes here.
Fomalhaut. How do you pronounce the lower left-hand star? Fomalhaut?
Pomelo.
Fomalo.
Well,
say Fomalhaut.
I think Chuck had a different pronunciation.
I
But
think I've heard Fomalhaut, but you'll hear all kinds of.
Fomalhaut.
Yeah.
Fomalhaut is what
a
I-
lot of my stuff, a friend of mine, when we were 11 years old, we made flashcards for major stars and where they were in the constellations and the constellation. And so we learned these things by heart, but we never heard any of them articulated orally. So we have our own pronunciation of all these things.
Tom, are you there? What would you call that?
Say Fomalhaut.
Fomalhaut. Okay.
That's German.
No,
No.
it's Arabic for mouth of
Arabic.
the fish.
Yeah, but it looks
Really?
French. So anyway, the reason Gary Saronic is here is that he wrote an article about finding Venus in the daytime. And I've done that with Venus and with Saturn, finding them in the daytime, especially Venus. Venus is very hard to look at night because the disk is so bright and the contrast is so big, your eye doesn't work well in that scenario. So seeing it in the daytime, you get much cleaner views of it. But you can't usually find it by naked eye in the day. What I did was I set up where it was going to be, or where it was at nighttime, except for the right ascension. And then during the day, I moved the declination would be right, and then I would move the right ascension till I could find Venus, till it floated into view. That's how I found Saturn, because you could see at that time, you could see it in the day and the night. Venus, that's not true. You have to know the right ascension and declination and set it on your setting circles. But it's cool to look at in the day, and I think you get better photographs of it.
But I've never totally understood why is it sometimes the morning, sometimes the night? What's the effect there? What's going on?
Well, it's an inferior planet. both Mercury and Venus. They're interior to us from the sun. So they're,
Oh, I understand that, but why wouldn't it just stay either night or morning, right? Does it go up and down like the sun does during the year?
Goes
They
round.
have faster orbits than we do.
it's,
Yeah.
it's either to the east of the sun or to the west of the sun. So it either shows up before the sun or after the sun, depending on morning or evening.
Oh, interesting.
Hmm. Well, that would make sense if it was above or below the sun, but it's not. It's on a platter that we're on, the same ecliptic. That's what.
But it's
Yeah.
tilted. It's tilted.
Is it tilted? Okay. Hmm. But it's the third brightest thing up there behind the sun and the moon, and then Sirius is number 3, but it's a star.
Well,
Sirius-
Jupiter can be brighter than
Yeah.
Sirius. And it is
Jupiter's
right
really
now.
bright right now.
Okay, but Sirius is the brightest star. That's of all
Yeah.
the stars. Yeah, okay.
Yeah.
Interesting. The stuff I learned.
And we can see Canopus now if you stay up late enough, and which is the second brightest star.
Sounds like a disease I have to deal with late at night. A bad case of Canopus last night.
Well,
Okay.
don't stay out too late tomorrow night. You'll get a bad case of Canopus again.
Yeah.
All right. Ooh. What is this?
Stefan's quintet.
We have covered this a bit on a few occasions. This, I came across a very nice annotated picture of it by Astro imager Tony Hallis.
Uh-huh.
So this is, these are,
Colliding galaxies.
yeah, these are here. This is one galaxy, second galaxy, third, fourth, and then a fifth one that's not really part of the group.
I thought, oh, okay. I thought 7320 was not part of the group, but I don't know.
It looks interactive to me, but let me see. I wrote it down somewhere.
There's 5
You're
here.
right. 7320 is a foreground galaxy, not one of the group. So this is the one where it's just accidentally in the line of sight. And it looks like you can see bridges of material going out there too.
You'd think old man Messier would have stumbled on all of them together and given it a one number, wouldn't you?
It's not bright enough for that.
They're pretty
Yeah.
dim.
Really?
Where's the fifth one then?
Well, you can see all the yellow arrows.
Yeah.
See, there's 2 cores right here in what you might think is one galaxy. This is 2 galaxies.
But you just said 7320 is not part of the quintet?
It
Yeah.
is part of the quintet visually.
Mhm.
It's just not physically associated with them.
Oh, okay. All right, good deal. Good deal to know. Good to know.
It's like the difference between binary and double.
Uh-huh.
Right. So does science think in a few billion years that's going to be one giant elliptical or spiral?
You know, they look a little distorted, so I think they might have already come close to each other.
Well, they're not all merging.
They are, except for
They
that
are.
foreground one.
Yeah.
These are pretty hard to see in a backyard scope, aren't they?
It
See 'em
depends
on
on
my
the size of
18,
your
yeah.
scope.
Yeah.
I saw them first in a 20-inch telescope, and they're faint fuzzies there.
Yeah,
The
I've-
article said you can see them in an 8-inch or 10-inch scope
Huh.
That's
from a
tough.
very, very dark sky site.
Right. I've seen them in my 18, Tim. And 7331 is kind of the launch to it. You use 7331 to jump to these.
Okay.
7320 looks like it's we're looking at it obliquely. We're not looking at it face on.
Huh.
Partially.
Imagine what the night sky would look like if you were orbiting a planet on one of those.
Yeah.
Well, you know, M81 is the same. You're looking at it not quite face on.
Yeah.
M82 has you're looking at it edge on.
Where's the quintet in the sky? What's a nearby?
Pegasus?
In the square of Pegasus.
Really? Okay.
Yeah.
Huh.
Come over sometime, Tim. I'll show you it.
Yeah. Absolutely.
If we were on a planet in this quartet, then we would see a very complicated Milky Way-like band across the sky, or clumps of bands.
Well, how do we know the little one at the top right isn't way distant beyond it? Can they measure the distance between those, the depth?
Yes,
They can.
from
They don't-
redshift,
they're in the same area.
except for
Red-
that one 7320, which is in front of everybody else.
Right.
Ah, got it. So that's like our local group finally coming together in a way. And
Yeah,
Mm-hmm.
party time.
it's amazing. And yet everything's flying apart, but a few little places where they congregate together, the galaxies are gathering together. It's amazing.
Gravity wins in that
Yeah,
case.
most of these star clusters, galaxy clusters, are gravitationally bound together.
Right.
You get blue shifts between some of the items.
And Messier's telescope couldn't pick this up.
Oh, no. Uh-uh.
Really?
He just had a little 3-inch.
Yeah.
Really?
So, yeah, I've seen him my 18. But I think that was probably at Lassen. You know,
There are things that he could have seen and maybe did see, but he didn't put them in his catalog.
yeah.
Has there ever been a case of something like this being totally obscured by a star in our solar system in front of it? But we got the feeling either through gravitational lensing or that there's something like this behind it, or is it
No,
that?
other than the great attractor, there's nothing like that.
Yeah.
Well,
We do see clusters of galaxies only by lensing, but they have to be very far away. All these other dots around here are stars in our galaxy.
Oh, they are.
Some of the blurry ones might be, like this is clearly a galaxy back there. And maybe this one. But anything with diffraction spikes like that is a point source. And there's a galaxy up there too.
Well, if those are all stars, then that group of galaxies colliding is pretty good size. You'd think you'd be able to see it.
You can see it.
Okay.
Now this is Messier's first object, M1.
M1.
Which if you're not careful, you will think of as a planetary, but as Chuck keeps pointing out to me, it's not a planetary. It's the result of a supernova explosion, and planetary nebulas are formed with smaller stars that don't go nova or supernova, like our sun will eventually form a planetary nebula. But this one is very violent. It happened in 1054, I believe. It was recorded by Chinese astronomers and maybe other places in the world too. You can watch it. We've been photographing it since the late 1800s. And so we have 125 years of watching it, and you can overlay things and you can actually develop a movie, and it shows everything expanding, the different parts of the gas. So it is growing in time. So take a bunch of pictures of it and compare them. This is a bunch of pictures that are all superimposed from 5 different observatories. The red in here in this shade, and these are all false colors, as all astronomical photos are. This is radio waves. The green here, some of it around there. Well, there's 2 shades of green. Good luck. So this is infrared. This is visual optical in the center of where our eye is sensitive. The bluish in here is ultraviolet, and the core vermilion, or not vermilion, that's a yellow, whatever that is, purple, cyan. Anyway, that stuff is X-ray, and they all contribute here. You can see structure in the center. You can see ring structure there, and these things are growing.
I think it's a little washed out.
Yeah.
Oh,
Just
is
see
it
that
washed out?
little tiny bit. Not bad though.
There are X-ray movies of it where you can actually see the pulsar pulsing and causing brightness variation in some of the little wavelets that you see in there. And there were optical observers that they knew the rate. They knew it was a 33 times a second or whatever it is.
Yeah.
And they made a little shutter that was blinking at that rate. And we're able to see the pulsar go on and off as they change the rate on their shutter.
Mhm.
Really?
Now, the pulsar of which he speaks is this bright spot there. Can you resolve regions that were washed out before?
Yes.
Yes, yes, much
Anyway, you
better.
can also see a ring around here
Hmm.
and probably a bow shock of some type.
Mhm.
And there's other structure that mimic that ring going farther out.
It appears to me that's kind of like a top. It's really spinning.
Yeah.
But this is not the sort of thing that gives us a nebula. We don't have a nursery going there. All
That's a
that.
nebula. Nebula just means cloud, but in this case, it's the remnants of a supernova.
Okay, are there planets and stars being formed in there?
No, this is
No.
debris from a single star.
Yeah.
There's not enough to condense into new stellar systems.
Well, there may be because it was a massive star, but it's moving outwards, so it's too hot basically to.
Right. This is one of those things that's the source of the gas and dust that goes on to become new stars. But right now it's just trying to hurry away from the scene of the crime.
Yeah.
So it was a Betelgeuse before it went, a big red one.
Yeah.
Okay. And
What you say by hurry is a little bit different.
what did you say, Tim? I didn't understand.
When Jerry said it's hurrying to get away from everything right here going on, that what he says about hurrying is we can come back decade after decade and it doesn't change that much.
Oh yeah, of course. But are all the new higher elements made in this sucker, and that's how you get?
No, not the really heavy stuff. Some might be, but it's the really stuff like gold and platinum gets made when neutron stars collide. So that's like that central object in there colliding with another one.
Really? So if two neutron stars hadn't collided, we wouldn't have any of that stuff on Earth.
Well, we wouldn't have as much. There's
Yeah.
some created in these energetic events.
The nebula that created us is long gone, right?
Yeah.
It's pretty much sucked up and gone away and become different stars.
Or just been dissipated. Yeah.
Interesting. The old crab. Is there a crab pear pincher? No, never mind. Makes
Now,
me
this
crabby.
is pictures, these are progressive pictures of that region around the neutron star, where December 95, December or February 96, April 96, and it shows the changes in the inner Crab Nebula. So you can see changes here and here, and you can see changes in the brightness and distribution of that.
Wow.
And some here and here. So there is stuff going on, and you can monitor this. This is only over what, 6 months, December to April, 4 months. So you can make movies, or there are movies, as Chuck alluded to, that go over years, show the whole thing expanding.
But that's the center of the Crab Nebula are two neutron stars.
No,
No.
just one neutron star. One of these is a star in the way.
The one with the diffraction spikes is in the foreground.
Yeah.
Oh, I see. It's not part of the nebula.
Yeah.
No.
Okay. And the difference between a neutron star and a white dwarf? Or is there?
Yeah, there is. Neutron stars are bigger
They
And
are.
denser.
and
But they're
denser.
mostly-
Yeah.
They're neutral.
Wait, I'm sorry. Neutron stars are smaller.
Small.
Neutron stars are
No,
about
but-
the size of a city. White dwarfs are about the size of a planet.
Yeah.
But which of them twirl and become pulsars?
That's neutron stars.
Neutron.
Only neutron stars do that. White dwarfs don't do that.
No, white dwarfs
Not to
don't-
that same extent.
Yeah.
Where they
If
have
they do
a
it.
beam going out on both sides, going up.
Whenever something shrinks and keeps its mass, it goes faster. It spins faster.
Called the ballerina effect or something.
Yeah.
Yeah,
No,
good.
ice skater.
Yeah.
So anyway, these pictures were taken at Arizona State University and are attributed to NASA.
Wow.
Of
Using
course.
Hubble. Using the Hubble, though.
Right, but
Oh,
the width pick was designed by Don McCarthy at Arizona, University of Arizona. The wide field camera, the width pick there.
That's
oh,
That's
Hubble
Don
Space
All
McCarthy.
this, all this
Telescope,
coding
wide-field
around
imaging.
here is, this is Hubble Space Telescope,
Right, that's the
wide
camera.
field camera.
Yeah, Don McCarthy's creation.
Yeah, okay.
Oh, wait till they aim the web at it.
Okay, well, now we come to
Another really useless.
the
You don't like these.
critique of this artwork is constant.
You know me, you know me, huh? I
Yeah.
know you.
You know me. This is a region in Taurus. It's hard to spot where it is on the sky because they emphasize other things, but I don't have time to redraw this onto a useful star map, so we have to endure these. So there's quite an interesting number of things up here. There is a Barnard dark nebula here.
oh, I like those.
There is an IC, which is an extension to the NGC catalog for fainter objects. And then there's an NGC cluster here. So there's a lot of interesting objects. Eunomia is near B29, and we're right about here, I guess. Well, January 1 is Thursday. We're right about there. So well, that's 2.5 days. So we'd be right about there. And it's heading down.
Down where?
South.
Coming our
South.
way?
Yeah. Now this is a picture of B29
Yeah.
without Eunomia in it. This was taken before Eunomia came along. This is a region that looks like the stars are missing, but actually it's a nebula, and there's other regions of it up here and parts there and there and there. It's a cloud of dust and gas, but it's not heated, so it doesn't emit its own light, and it's not near enough to a hot star to reflect that star's light. So it's a dark nebula.
So if they attempted to do a deep field right there, they'd get nowhere, would they?
Yeah.
Depends
Except
what
in the
wavelength they
infrared.
were looking at.
All right. Fascinating.
With radio telescopes, you'd see right through this.
Somehow it's hard to find a dark spot, a dinky one that you can go far enough. The deep field that both Webb and Hubble did, they had to find the right spot.
Yeah.
No, they just picked a dark spot and sat there and looked at it for 100 hours or so.
Well, no dust there where that dark spot is. What is this?
This is let's see, this is M38. This is in that region.
Yeah, it's in Auriga.
Yeah.
Yeah, 1907 is a nice open. Seen that a lot.
This is IC4. Oh, that's what I was looking for. This is IC410, which is this one up here, 410.
Which is another asteroid?
No.
It's actually a star cluster embedded in this nebula.
Mhm.
Oh, okay.
So
But
you will.
we're talking about a rock here, aren't we?
No. We're not right at the moment.
Yeah,
Oh.
Eunomia is the rock, but it's not in this picture.
Oh, I got you.
This is showing highlights of the region where Eunomia is. So if you look at this and take pictures one night, this one is actually where Eunomia has left. So you probably won't, and this is a wide field picture, so you're probably not going to get Eunomia in this. But take a picture on successive nights and you'll see it move. If it moves and it doesn't have a tail, it's an asteroid. If it moves and does have a tail, it's a comet.
Well, do these rogue asteroids that we focus on, are they in the belt or are they just wandering own orbits?
We look at both kinds, but in this case, this one's a main belt asteroid.
Yeah.
Oh, okay. So it's not going to leave the belt. Interesting.
And this is another picture of stuff up there. It's called the Tadpole Nebula.
Tadpole, there they are.
And this has IC. This is IC410.
Yeah.
So, but in white light. The other picture was a wide angle view in H alpha, I believe.
So Chuck, do you see the credit down there on the right?
Yep.
I figured you
He's the
would.
night.
Carpe noctem, yeah.
Not Tim.
And this, whoops, oh, see, this is that way of looking that it doesn't honor my numbering system.
Okay, we're back on Parker now, or
No.
okay. Just jumped in here and we're
I'm
changing.
working on it.
Right, we're just parked on it for the moment.
Yeah.
Okay.
I have I observed one of the occultations of Eunomia. I think it's been seen 3 or 4 times in occultations,
Wow.
and I have the results from it. Should I try sharing that?
Yes, please try.
All right. Oh, someone else is sharing, so I think, Jerry, you'll have to stop for a moment.
It says the Zoom meeting is not responding.
Uh-oh.
Close the program. I may be off site a bit. Go ahead.
Yeah, you've frozen. Your face is frozen.
Yeah, I can't share because it says someone else is doing it, so.
What are we trying to share, gentlemen? Can we talk about it?
I participated in an occultation of Eunomia back in May of 2023. And there were 2 other people that got hits on it, and so they superimposed a shape model. There are a couple of shape models for it based on how it varies in brightness.
Right.
And so you can take those shape models and rotate them around until they match the occultation. So you get some idea of the orientation of the asteroid at that moment, and of course a good position on it. And it also helps differentiate between different shape models, which you may get, because sometimes the
Are you
modeling
sharing?
of the
Try
shape
now, Chuck.
based on
Are
the
you sharing?
brightness is ambiguous. Okay, let's see what we get here.
I'm gonna have to mute out, guys. I have a tree trimmer here and it's really loud.
What's
Okay.
that?
Yeah.
We don't hear it.
Okay, you comedians. Okay.
Okay, is Eunomia showing?
Yes.
Okay.
Good job.
So there's the 3 different chords going across it from people who did the observations. Mine was the purple one at the bottom. So I had the poorest match.
It occulted a star, right?
Yeah.
Do you remember the name of the star? Was it a memorable one?
No, it's going to be one of your telephone numbers.
Okay.
I mean, I could look it up, but
But because you had the lower one, that would be the edge of it. You only saw part of the star occulted?
no. The asteroid's big enough that the entire star gets covered. The star is essentially a point source.
Yeah.
It's
Why
just that
are there different tracks portrayed here in different
because
colors?
there were 3 people, 3 of us that saw the occultation at the same time.
On different places on the Earth.
Different places, Ron.
Just 3 in the whole United States or around the world?
Yeah, they were all in let's see, Kirk Bender, Rich Nolthenius, Jay. So one guy was in Nevada and the rest of us were in, it's 4 of us, I guess. And the rest of us were in California.
Okay.
Okay. So there's a wide path, just like an eclipse that goes across the Earth.
Exactly.
Mm-hmm.
And we happen to be in it, and so did Nevada. That's a wide,
Well, this is a big asteroid.
really?
Yeah.
Yeah.
It's one of the larger ones in the asteroid belt.
It's not as big as Ceres, though. It's not a,
No.
No, it's not.
No,
that
but it's like here it is. It's 248.3 kilometers across.
okay, that's about 150 miles.
Yeah.
Okay. Wow. Okay. And it's in the belt. So you're looking out at past Mars.
Yep.
The ones that are rogue, they're not part of the belt, are they? Their elliptical orbits may go up into it and come back, right?
Yeah.
Come close to us.
Yeah, and there are ones that stay farther out too. And then there are Trojans. So there's all kinds of
Yeah, the Trojans are in
animals.
Jupiter's orbit. This, in front of and behind Jupiter. We can't see any in that orbit, can we? That's too
Yeah.
far out.
No, you can see them.
Are there any dwarf planets in the Trojans?
No, not yet.
Okay.
I
It
don't
says
think they'll
with-
count them as dwarf planets because they sort of are dependent on Jupiter's gravity.
But for some reason, they're stuck in some sort of Lagrange point on the Jupiter orbit, right?
Yeah, because those are spots where things cancel out, so they're stable points.
Mhm.
One ahead and one behind.
So
Interesting.
Wikipedia says that Eunomia is a large asteroid in the middle asteroid belt. It's the largest of the stony asteroids, with 3 Juno as a close second. It's quite massive at sixth to eighth place within measurement uncertainties. It's the largest Eunomian asteroid, so apparently it has a class, and is estimated to contain 1% of the mass of the asteroid belt.
Wow.
So it's pretty big.
Yeah.
It's
I'm
also
sure-
believed that Eunomia is the result of a collision and was on its way to being differentiated big enough to do that when it was hit. And this is the remaining core. And that's a speculation.
And that Eunomia family would be the pieces.
Yeah.
So there's no basic scientific theory that the whole belt is the remains of a planet that was
No, no,
really?
no.
The Jupiter, I guess it's within the Roche limit for Jupiter. And so if it tried to form, Jupiter would pull it apart.
If
So
what's
it's never been a single body.
The stuff in the asteroid belt, Ron.
Right.
well, I have a hard time seeing things that small condense just from gravity to becoming that hard, like a rock. There's not enough gravity to make a rock out of dust.
Once you make a big enough collection of stuff, the gravity starts compressing it and the core gets hot and it
Yeah.
melts and
Yeah,
and plus you have radioactive elements contributing heat.
Right.
And
So
so the thing differentiates.
Baron, think of where rocks come from on Earth.
Well, they're part of a bigger rock
Yeah.
called the Earth.
Yeah.
And the Earth was made out of piles of them.
I mean, we see a lot of comets and asteroids that are nothing but piles of rubble.
Yeah, we do. Eunomia is not a rubble pile. That's been established.
That just leads me to think it was part of something much bigger earlier.
No?
Yes.
Really, they can condense and become that hard.
Yeah.
Piece of granite in space.
Well, granite's a special case.
Yeah.
Oh, is it? How
Yeah.
about marble?
Now, marble's a special case too. There's no seashells in space.
Yeah.
Well, what are they made of? Are they all pretty much the same, or are they like different strata down here on Earth?
What do you
Well,
mean?
if they've differentiated, you have different strata.
Yeah. Right. Differentiated mean it went together as a bigger unit, or it was on the way to do that. And in this case, they think it got hit before it could complete the process of differentiation.
Okay, but Jupiter's the culprit here, keeping it from being a planet, keeping all of.
Jupiter
How big
tends
would
to
the Jupiter
dominate
be?
our planetary system in many ways,
Uh-huh.
some beneficial, some not.
Well, I'm aware of that. 10 hours in its orbit, in its rotation. My God.
Yeah.
Okay, we're
So
back
here-
in space here.
We're back looking at in the Tadpole Nebula, the cluster NGC 1893.
Actually, it looks like
There's either,
sperm in the cell. I'm sorry.
there's either an asteroid or a satellite in there at about the 3 o'clock position. Come out a little more.
Right there.
Right there, yeah.
Yeah, you're right.
That's what a line means. It's moving.
Yeah.
How long of an exposure to get this picture, you suppose?
Mike, I don't have that information, but I can tell you it was longer than a snapshot.
Yeah.
And it's probably multiple layered exposures.
And there are the tadpoles again at the 11 and 12 o'clock-ish.
I prefer to call them sperm.
The tadpoles. Well, they're very misguided.
Well, are we looking at a nebula?
Yes.
That's a
That
nebula.
was a star cluster in a nebula.
Ah, fascinating outer space. Okay, back to the night sky. There's old Milky.
There's our winter triangle.
Where?
Well, Betelgeuse, Procyon, and Sirius.
Oh, not outlined. All right.
And so we're looking at Canis Major down here with the brightest star in the sky, because this is the winter. And
The Pleiades.
Yeah.
this, we're looking at the Pleiades.
No, the
Oh,
Pleiades,
yeah.
M41.
Pleiades,
Yeah,
yeah.
right there, yeah.
Oh, okay.
Whoop,
Hmm.
careful with that cursor there.
You can use it to make it large. Blow it up. There we
Okay,
go.
so there's the Pleiades up there with the name, or there's 8 names, so 7 sisters. I guess they brought a friend over. But the major thing is that this is a very rich region, as we mentioned. Sirius is the brightest star down here, but close to it is M41, the star cluster. Quite a ways from M42, which is the Great Nebula in Orion. But right down here, close to Sirius, is M41, right there. And that's another winter object. This is a photograph of Sirius and M41 down here.
And because they're in the middle of the dog, they're sometimes called the Pleiades.
The Pleiades.
Pleiades. Is Sirius a binary?
Yes.
Yeah, it's got, because it's called the dog star, its small white dwarf companion is sometimes called the pup.
Oh,
So the bigger part is another red giant?
No.
Well, it's not a red giant. Otherwise,
Main sequence
Sirius
star.
B, right?
Sirius B is the pup.
Okay.
is it so bright because it's closer than most stars?
Yes.
Yes.
That's the closest star to our sun that you can easily see from Santa Barbara without binoculars or a telescope.
Aha.
It's about 9 light years away.
Well, it probably is going to be part of the speech of this Friday night's guest from Cal State Northridge, Dr. Christian. He's going to talk about nearby stars and
Okay.
possible
Yeah, I believe
extraterrestrial.
he'll be including that.
I would imagine he'll certainly do Proxima, I guess.
Well, if he's talking about exoplanets, yeah, he'll do Proxima, but probably not Sirius.
Sirius doesn't have any orbiting.
It has no known planets.
No kidding. Well, we'll wait and see.
Yeah.
That's-
So the final pièce de résistance is the quadrantid meteor shower, named after a defunct constellation, the Quadrant. This
we got to
show,
learn how to pronounce. We got to
What's
learn how
that?
to pronounce it. We got to learn how to pronounce that Danish, Dutch name, Boötus.
Boötus.
Greek.
I hear boots. I hear boots.
Okay, boy.
It's Greek. It's Greek, Ron.
Booties.
It's Greek.
Yeah.
Greek
Well,
has-
it's got an umlaut over it, which when I took
Boötes.
German, it meant O with a slight R sound, Boötus.
No, it's
No,
Boötes.
No, it's just to give you another syllable.
Yeah,
Right. Boötes. That's how I say Boötes.
yeah, that's how I say it too.
Booties.
Otherwise, it would be booties.
Yeah, I say I always go Boeties. Boeties.
Okay, so this is not a star up here. This is called the radiant. This is the radiant where all of the meteors appear to come from.
Quadrantid. Let's see. Quadrantid.
Quadrantid.
That's right.
I'll be darned.
And the peak for us is at like 7 a.m., so it'll be a pre-dawn thing.
Yeah.
And Vega came up this morning around 5.
Okay.
So this projection is from one of the 2 Astro magazines, and it's for January 3rd, which is Friday, Saturday.
Friday.
Friday. Friday?
Friday at
meeting.
4 a.m.
Friday at
The
4
meeting.
a.m. Okay.
And
And-
for us, I don't think Vega's up, right? So 5, well, with our mountains.
Yeah, I see it at 5, Chuck.
Okay.
Really bright.
So this is a photograph of a quadrantid meteor shower from an all-sky camera at an observatory, and it was in 2021.
With a bright fireball, yeah.
Yeah, it's got a nice long bright trail, so it should be a good meteor shower this year. The moon is near new or at new. And so it should be a good show. Very dark skies.
And you can
At
see the
my
big,
house may be very foggy, but yeah.
and you can see the Big Dipper there near where your cursor is,
Mm-hmm.
and arc to Arcturus. And so when you see where it originated near the building there, that would be Boötes.
Yep.
Yeah.
Well, because the horizon curves around, does that mean it was directly overhead?
Pretty much.
This
much.
camera was pointed straight up.
Oh, got it. All right.
Yeah.
So it's a
It-
fisheye
it's-
lens.
So you can see the Dipper pointing to the North Star, Ron. See
Right.
that?
Would
Right
we
there.
be able to see part of the Milky Way?
Not in the
This-
north like that.
Not
Yeah.
there.
But it's light around the edges.
City lights.
Yeah, city lights.
Oh. I love the fact that there's always a meteor shower, there's always a comet coming through, there's always an asteroid.
Yeah, I saw an errant from this last night about 10 o'clock.
You saw what last night?
An errant, a precursor. I saw one go right across the sky.
Oh. Wow.
The
Just
these
imagine it.
meteors typically are moving about 25 miles per second.
Is that
and-
right?
You can expect about 80 meteors per hour
Mm-hmm.
for a few hours.
And it's a grain of sand going that fast, right?
Yep.
Mm-hmm.
You all know
That long a streak, they're probably closer to small marbles.
Yeah.
One thing I've learned from this is the escape velocity to get in orbit around the Earth is what, 17,000 miles an hour?
Mhm.
17,500 in low Earth orbit.
So all those
It's
little, all those
11
escape
kilometers a
velocities-
second, Ron. 11 kilometers a second, something like
Right.
that.
That's
How-
escape velocity. That's if you set the rocket on the grass in your backyard, how fast does it have to take off in order to never come back?
Yeah, 17.5.
Now, this is an all-sky camera at NASA's Marshall Space Flight Center in Huntsville, Alabama.
Okay.
Is that right? You suppose they
And
can
it
turn
looks
it
like-
into a regular flat picture?
Looks like there's a number of
Buildings.
Light
lights in
pollution.
here, probably parking lot. Looks like cars over there or buildings or something. So was not an ideal thing to capture this, but they did a good job.
Well, this has been fascinating, gentlemen. I got to tell you. Did we get to Stephen's quintet? We did that earlier, didn't we?
Yes.
Yes.
I got to tell you, Jerry, on behalf of the crowd on the screen, we really appreciate the work you do. I got to tell you, this is the
Okay.
time to do it. We're switching over a new old year back to a new year, and we're going to have our 4th year starting in March. But you put a lot of work into this, man. Seems like you enjoy it, though. And we enjoy coming along for the ride. I do anyway. Chuck,
That's one thing I learned in aerospace is view graph technology.
is that right? Well, we're in like
Ronnie.
Flint for another year at least, and I think our club's growing, and this shows
Seems
no
to be.
sign of. That was number 201, everybody. We'll be back after our meeting on Friday night with a New Year's version, number 202, a week from today. We thank you. Happy holidays. That's it for the SBAU Astro Hour. I
May see you later, Tommy.
Yep.
Okay.
Happy
Tim.
New Year, everybody.
Thank
Happy
you.
New